Now we will discuss about renin, angiotensin, aldosterone system, that is simply called RAAS, which is an important mechanism which regulates our blood pressure. So the three things mainly here: renin, angiotensin, and aldosterone. There are three things which regulate this RAAS system. In details we will discuss. Before going, first of all, we will discuss first thing is renin. So renin is a hormone which is released by our kidney and it reaches to our systematic circulation and it is our liver. So liver releases one protein which is called angiotensinogen, a precursor, which is converted to angiotensin 1 in presence of renin. Then this angiotensin 1, when it circulates to our lungs, that is lungs, and it is liver. So when it circulates in our lungs, and in our lungs there is an enzyme which is called angiotensin converting enzyme, which convert this angiotensin 1 to angiotensin 2, and this is a very important vasoactive substance, this angiotensin 2, which regulate our blood pressure. So how it regulates. This is the nephron and this is collecting duct, and it is adrenal gland. So angiotensin 2 work on adrenal gland to release one hormone which is called aldosterone, and this aldosterone work on distal convoluted tubule, the last part, and it reabsorbs sodium and water. And by this increase blood volume and finally it increase blood pressure. In the meantime, it absorbs water and sodium, and meantime it releases potassium into the urine. So first mechanism of angiotensin by which it increases blood pressure by releasing aldosterone. That's why it is called renin, angiotensin, aldosterone system. This angiotensin 2 in our blood vessel, one receptor is present, what is called angiotensin 2 receptor. So it binds to this angiotensin 2 receptor and it causes vasoconstriction. This diameter is decreased, so vasoconstriction. So due to this vasoconstriction, the pressure is increased, blood pressure is increased. So this is second mechanism by which angiotensin 2 work and increases blood pressure. Third mechanism, angiotensin 2, which work through hypothalamus and posterior pituitary gland. It stimulates the hypothalamus and finally from that posterior pituitary hormone, it releases ADH, antidiuretic hormone, or it is called vasopressin. That vasopressin or antidiuretic hormone works on collecting dirt and increase the reabsorption of water. So water reabsorption would take place. And finally blood volume increases and then increases blood pressure. So this is the third mechanism. And angiotensin 2, next mechanism, it is a very strong stimulator of sympathetic nervous system. And through the sympathetic nervous system, this angiotensin 2 increases cardiac output by increasing the heart rate and force of contraction, and increases blood pressure, and also by sympathetic actions it cause the vasoconstriction and blood pressure is increases. This is the simple basic mechanism by which renin, angiotensin and aldosterone system works. So now we will discuss in details how renin is released. How renin is so see, it is a glomeruli. In the glomeruli, this is afferent arteriole and this is our afferent arteriole. Suppose through these afferent arterioles blood comes to the glomerular and filtration will take place. In the below of the afferent arterioles there are some cells, smooth muscle cells are present. When there is a decreased blood circulation and the pressure on this will decrease, on this smooth muscle will decrease, and that time this cell releases renin simply. And this is due to the difference of diameter. Afferent arteriole diameter is less than if afferent arteriole. So due to this pressure is created. When less blood pressure will be there, then less blood flow to the glomerulus will occur, and due to this less pressure is exerted here on these cells, and that cells will release the renin. Similarly, so suppose this is the proximal convoluted tubules and loop of Henle and proximal convoluted tubule, and this is distal convoluted tubule. Normally what happens when this glomerular filtrate will take place, most of the things will reabsorb, mainly in case of sodium ion. About 75% sodiums are reabsorbed in proximal convoluted tubules. Around 20% are reabsorbed in the loop of Henle, thin and thick loop of Henle. And finally 10% of sodium reaches to the distal convoluted tubule. In the distal convoluted tubule also there are some cells present which are called macula densa. When there is a less blood circulation, then less filtration will take place, and this filtrate will move slowly. Then most of these sodium ion are absorbed in proximal convoluted tubules, and by that way in distal convoluted tubule the concentration of sodium ions remain less. Due to this less concentration, and they releases mainly nitric oxide and some prostaglandin which stimulate these cells, smooth muscle cells, be attached with afferent arterioles and to release renin, and this totally called distal convoluted tubules and along the cells present with afferent arterioles are called juxtaglomerular cells, and which is nothing but which releases as renins or juxtaglomerular apparatus. So by that way renin is released, and which is finally restore our systematic circulation. And our liver, we know that continuously it releases angiotensinogen, and that angiotensinogen is a precursor and which is converted in presence of renin to angiotensin 1, and finally that angiotensin 1 reaches to our lungs, and in our lungs some endothelial cells present in, this is suppose alveoli of lungs, around this alveoli pulmonary capillaries are there. These are pulmonary capillaries through which blood circulation take place. So in that some endothelial cells are there. These are endothelial cells. So these cells contains one enzyme which is called angiotensin converting enzyme. When angiotensin 1 will come to this through our lungs, and angiotensin converting enzyme convert this angiotensin 1 to angiotensin 2, and this final angiotensin 2 regulate our blood pressure